Alright, this is part 10, long-term liabilities. This is going to take years. So long-term liabilities are amounts owed to others that will not be paid off within 1 year of the balance sheet date. Most of the time we look at these, study these, in terms of notes payable and bonds payable. And we're going to save bonds payable to a later video, probably in the intermediate series. So we're going to look at notes payable in this particular video. Both of these are mechanisms through which companies borrow funds from other people. So Carl decides to purchase a company truck for moving canoes and delivering them to different sites along the river. The dealer is selling the truck for $10,000. Since Carl lacks the funds necessary to purchase the truck, he approaches the bank and asks for a loan. The banker says, "I'll loan you $10,000 for 36 months at 6% interest. Your monthly payment will be $304.22. And Carl is basically like, "What? Where in the world did she get 304.22? Is there some fancy machine or something that just spits out that number?" Well, to figure this out and to understand where these things come from, we have to look at interest. And interest is the payment for the use of money. Now, there are two types of interest. There's simple interest and there's compound interest. Simple interest means you earn interest on the principal amount only. So, if I invest $5,000 for 3 years and I earn 8% per year, I get $400 each year because I'm only going to earn interest on the $5,000 that I invest. So my total interest earnings would be $1,200. That's simple interest. Compound interest is different. Compound interest, you earn interest on the principal and the interest that you earn as time goes by. So, in year 1, I'm going to invest $5,000. I'm going to earn 8% interest. So I have, at the end of that year, $400 in interest that I've earned. In the next year, I'm actually going to earn 8% interest on the $5,400. So I earned $432. And then in year 3, I'm going to earn interest on the $5,832. So I earned $467. So in total, I'm going to earn $1,299 in interest. Now, which one do you prefer? Compound interest gives you an additional $99 for the same investment. And compound is the typical interest computation that we have when we run into business situations. So, compound interest is important for us to understand. Now, when we look at interest problems, there are 4 fundamental variables. You have an interest rate. You have a present value. That's the value today. You have a certain number of periods or time. And then you have a future value. And so if we look at a situation like this, where we are going to invest $10,000 today for 3 years, 6% interest per year, compounded annually, so interest is figured out on an annual basis, what is it going to be worth 3 years from now? So this is a time value of money problem, is what we call them. And in order to figure this out, we could do a table just like we did. So we could do a table like this, where we multiply the $10,000 by 6% interest, figure out what we earn, add it to our original amount, multiply that by 6%, figure out what we earn, add it to the original amount, and so on. And for 3 years, not a big deal, not that hard to do. But just imagine if your interest was in saving the money for 20 years. Pretty sure you don't want to do 20 rows of calculations. And so we have formulas that we can use to figure this out. The formula for a future value is the future value equals the present value times a future value factor for a certain number of periods, that's the little n, and a certain interest rate, which is the little I. And in this scenario, this is what it looks like. So our future value would equal 10,000 times the future value factor for 3 periods at 6% interest. Now the math for that looks like this. A future value factor is equal to 1 plus the interest rate to the number of periods. So plugging it in, we end up with an equation like this. 10,000 times 1.191016. And if we do the math, we find the future value to be $11,910.16. So if we invest $10,000 for 3 years at 6% per year, we're going to get $11,910 by the time we're done. So that's a future value problem. But a lot of times in accounting, our issue is not figuring out a future value. Okay, it's figuring out a present value, which we'll get to in a second. But you may not like to do the math for these future value factors, and the good news is you don't always have to. Most of the time we have what are called future value tables. They look like this. So across the top you see all the interest rates. Down the side you see the number of periods. So in our case we had 3 periods at 6% interest. So this yellow box, 1.19102, is the factor. And that's the factor we came out with too. We had 1.191016, which rounds up to 1.19102. So we can use tables and just look up the numbers, which is pretty nice. So what if we have a situation like this, though? Okay, this is a bit different. This is what we call a present value problem. Somebody promises to give us $10,000 3 years from now, and in our investment portfolio we can earn 6% interest. So what does that mean today? What is it equivalent to in today's dollars? Well, we need to find the present value, and so we have a formula for that too. Present value equals future value times the present value factor for a certain number of periods at a certain interest rate. And so in our case, the present value equals the future value, which is 10,000, multiplied by the present value factor, 3 periods, 6% interest. In order to calculate that, we use a formula like this. 1 divided by 1 plus the interest rate to the number of periods. So if you do the math in this case, we end up with a present value, missing a V there, a present value equal to 10,000 times 0.839619. And we find the present value is equal to $8,396.19. Now, like we did before, if you don't want to do the math, we can use present value tables. So present value tables look like this. Very similar to the future value tables, they just have different calculations built into them. So for 3 periods at 6% interest, our factor would be 83962. And that's basically what we came out with. So present value tables, future value tables, it works really well in helping us figure out, what is it worth in the future or what is it worth today. So let's look at our truck here. Let's say that the bank gave us just a basic note. They're going to give us $10,000 today that we can buy the truck with. We're going to have to pay interest on the truck. What formula do we use for that? Yep, we use the I-party formula. Interest equals principal times rate times time. And so in this case, the $10,000, we're going to pay 6% per year. and that is $600 per year. So we're going to pay $600 a year for the next 3 years, and at the end we're going to pay the $10,000 back. That's a basic note problem, cash flow situation. So what does that look like in terms of our journal? Well, when the note is issued, we would get the cash of $10,000, and we'd have a note payable of $10,000. We'd use the cash to buy the equipment, right? Or we could just simply debit the equipment account. So we get the note issued, $10,000, and then we pay the interest every year, right? $600 in cash, interest expense. $600 in cash, interest expense. And then at the very end, we pay the note back, $10,000. Note payable, debit, credit cash for $10,000. Now this is the basic note problem. This is what many businesses get between businesses. But for us, right, as individual people, that's not going to happen, right? The bank is not going to let us, most likely, take the $10,000 today and pay the $10,000 back 3 years from now. The banks typically don't trust that we will save, right? That individual people will save the $10,000 over those 3 years to pay them back with at the end. So in business-to-business situations, yeah, maybe this kind of scenario would work. But for the most part, even in some business-to-business situations, we're going to be looking at what are called installment notes. So installment notes, the payments when you have an installment note include both a part that goes to pay back the loan and a part that goes to pay interest. So if you buy money, or if you borrow money to buy a house, if you borrow money to buy a car, your student loans, right? These are all installment notes. And so let's take our truck scenario here. If Carl wants to purchase this $10,000 truck, and the bank is willing to lend him the $10,000 for 3 years, 6% interest, they're not likely to take one payment a year. They're going to want payments on a monthly basis. And so our N, the number of periods, is not 3. It's actually 36. 36 months, right? For 3 years. And the interest rate is not 6%, because that's 6% per year. The interest rate should be 0.5% per month. So before we get further into figuring out how that all is going to work, we need to look at another interest scenario. So in this interest scenario, we have the same 4 variables: interest rate, present value, number of periods, future value, and we're going to deal with the same timeline as before. But this scenario is a little bit different, because instead of just receiving one sum of money in the future, we're going to receive multiple sums. We're actually going to receive equal payments at equal intervals. So we're going to receive $1,000 at the end of the next 3 years. Now, when you have equal payments at equal intervals, this is what we call an annuity. And so to figure out what the present value of this annuity is, there's a couple things we could do. We could do a present value calculation for $1,000 1 year from now, $1,000 2 years from now, and $1,000 3 years from now. But that would require 3 calculations. And if it was 20 years, it would require 20 calculations. So, I don't know about you, but I'd rather not do that. It's because we have equal payments and equal intervals, we can actually use an annuity formula. So, here's the present value of an ordinary annuity. It is equal to the payment amount, which in this case is $1,000, times the present value factor of an ordinary annuity for a certain number of periods at a certain interest rate. And so, in order to do this, we know the payment amount is $1,000, And we need the present value factor for an ordinary annuity of 3 years, 6%. To do that, we have to do this math, which is a little more complicated than the factors we did before. If we plug in the numbers to the math equation here, we will find that the present value of an ordinary annuity of $1,000 for 3 years, our factor is 2.67301, and so the present value of that annuity, all of those payments, today have a value of $2,673.01. Now, again, like before, if we don't want to do all that crazy math to figure out the factor, we don't have to. We can use the present value tables. So here's the present value table for an ordinary annuity. We would go 3 periods, 6%. We get 2.67301, which if we look back, that was the factor we came out with all the crazy math. So present value tables, future value tables, they're really nice. And in most introductory accounting textbooks, you can find them in there somewhere. So we go back to our problem. This is an annuity problem because the bank is going to want us to make payments not even once a year, but we're going to have to make payments once a month. And so we have an annuity payment because each payment we make over the next 36 months is going to be exactly the same amount. And so we can do the math here. The present value of an ordinary annuity equals the payment times the factor. Now in this case, we don't know what the payment is. That's what we're trying to figure out. But we know what the present value is because we know the bank is going to lend us $10,000 today. And so the $10,000 is the present value. The payment we don't know. And the factor we can figure out. Now, most of the time for stuff like this, you're not going to find this factor in a table because, again, the interest rate is 0.5% per month. And a lot of tables don't have 0.5%. So we would have to do the math if we didn't have another option. That I'll show you here in a second. So we can plug in the numbers here to our math equation. And we find that 10,000, which is the present value, is equal to the payment times a factor of 32.87102. And if I want to solve for the payment, I simply divide both sides, right, by the 32.87102. And I find that the payment should be equal to $304.21, 22 cents if we round it up. Okay, so again, not altogether complicated to figure out, but there's an easier way to do this. If you will go on a journey with me here to Microsoft Excel, okay, most of you have this program or a similar program on your computers. When you go to Microsoft Excel, you click on the function button here. It brings up a list of typical functions that you could perform, formulas. One of those is PMT, which is payment. So if I click on that, it asks me for an interest rate. In our case, we know that the interest rate is 0.5%, which is 0.005. The N per the number of periods, we know from the bank, are 36. And the present value, the PV, present value, we are borrowing $10,000 today. Those are the only things we need to plug in. And Excel will do the math for us. It's even showing us right down here what the answer is going to be when we click Done. Okay, the answer is 304.22. Now, Excel lists it as a negative because it's assuming it's a payment, it's an outflow. But it doesn't matter whether it's a negative or positive when you're just looking for the number. So in a couple of seconds, right, Excel can tell you what the payment would be on that particular loan. Now there could be other things that complicate the scenario, but very basically that's how it works. Okay, so Excel is very handy to do things like that. Now, once we know the payment amount, we're going to pay $304.22 a month for 36 months. It's not a crazy complicated machine that he spits out this number. It all has to do with the interest and the time value of money. So, moving forward, what does this look like in the journal? Well, when we issue the note, when we borrow the money, right, we're going to get the truck. So we're going to record equipment of $10,000. And we're going to have a debt. We're going to have a liability that's attached to it. A note payable. Then, in the first month, I make my interest payment. I know how much I'm going to pay. I'm going to pay $304.22. But with installment notes, right, the payment includes both principal and interest. So the question then is, how much of the $304.22 is interest? And how much goes to paying off the actual loan or note payable? In order to answer this, we have to build an amortization schedule. Now, amortization. It's kind of a weird word, but we use it a lot in accounting. Amortization. It's from Old French, amortis. It's a lengthened stem from amortir, based on Latin ad, which means to or at, and mors or mort, which means death. So basically means to die, or death, or to extinguish or annihilate, put an end to. Amortization. So essentially, if you want to think of it in very simple terms, an amortization schedule shows you how you're going to kill the loan, how you're going to make it go away. Okay? So, this one, it's kind of long. It's much longer than most you would see in an introductory accounting class. But for the sake of our illustration, this is more realistic to what an actual amortization schedule for a car loan or something would look like. Most of the time, introductory accounting texts don't have monthly payments. They might do annual payments. So then you got about 3 lines on the amortization schedule, not 36 lines. But if you can do 1 line, you could do 100, because they all work exactly the same. So let's take a look at this thing. The amortization schedule starts with the amount of money that you owe, which is $10,000, month 1. Okay? The interest expense, the interest portion of your payment, is going to be the beginning note payable balance, which is $10,000, times the interest rate, which we know the monthly interest rate is 0.5%. So if we take 10,000 times 0.5%, we get $50 in interest. Now the payment is $304.22. So we take the payment, we subtract out the interest portion, and the rest is repaid principal, or the amount that's going to go toward actually paying off the loan, $254.22. Now, where does my loan stand at the end? Well, I started with a $10,000 loan. I've paid off $254.22. So I end with $9,745.78. And that's what I begin the next month with as my debt. I pay the interest on that amount, which is $48.73. $48.73 in interest. My payment is $304. The difference is how much goes to principal to actually pay the loan off, $255.49. Okay, and so my debt at the end of month 2 is $9,490. And so that works that way from one line to the next, all the way down. And you see at the very bottom, mostly due to rounding a little bit here. By month 36, what's my debt? My debt is 0, basically. Okay? And so this is an amortization schedule. It shows you how much of each payment you make goes toward interest or goes toward actually repaying the loan. And if you look at the differences in these columns, you see something. The interest expense starts at $50, goes all the way down to $1.51. The repaid principal starts at $254 and goes up to $302.71. And so if you graph these, okay, they look like this. The interest is graphed from the left side and the principal payments graphed on the right. And so as you see as time goes by, what happens to the amount of interest in each payment? It goes down. What happens to the amount of principal in each payment? It goes up. Okay? So because of this, the sooner you can pay off a loan like this, the less interest you're going to pay. Now, back to our amortization schedule. I'm trying to figure out how much of my payment, right, goes toward interest and goes toward the principal. And my amortization schedule tells me that. And so for my first payment, my cash payment is $304.22. Note payable is going to come down by $254.22, which is the principal repaid, and the interest expense is going to be $50. I pull that from month 1 in my amortization schedule. Month 2, same thing. Payment's the same, but the difference between the principal paid off and the interest change, right? And month 3, same deal. Cash payment stays the same. Amount of interest paid is $47.45, and the note comes down $256.77. So you would make these entries every month, right, as you make your payments. And those 3 rows right there, those 3 shaded rows there, those are the numbers you would use in your journal entries. So you have all the numbers you're going to need to journalize your installment loan payments for all 36 months once you build your amortization schedule. Now, these yellow shaded numbers, those are the amount of the principal that you owe that you're going to pay off within the next 12 months. And since they're going to be paid off within the next 12 months, they are current liabilities. And so the $3,135.95 that's going to be paid off within the next year is called the current portion of long-term debt. So it's going to be reported on the balance sheet as a current liability. The rest, okay, what remains, which is $6,864.05, is going to be paid off in the years that follow. So that number will not be paid off, right, within the next year. And so it is a long-term liability, what we often refer to as long-term debt. So when we build the balance sheet here, the equipment is going to show up on the balance sheet. The equipment account will show the $10,000 cost of the new truck when it's purchased. And then our liability section, the current portion of long-term debt, is presented as a note payable under the current asset, not current assets, that's a typo, current liabilities portion of the balance sheet. And the amount that will not be paid off within the next year will be presented as a note payable that is long-term, okay, listed after the current liabilities. So, in summary, long-term debt, long-term liabilities are amounts owed to others that will not be paid off within 1 year of the balance sheet date. Most long-term debt almost always means that the company will have to pay interest. The current portion of long-term debt must be reported as a current liability. In order to determine the payment on an installment note, one must use present value calculations. In order to determine how much of a payment is applied to the principal loan and how much is interest cost or expense, one must prepare an amortization schedule. So, fun stuff here. As always,